So, you probably hear this every single day. The whole doom and gloom narrative that the artificial intelligence revolution is coming for everyone's job.
Oh, yeah. It's everywhere. People are terrified.
Right. But the CEO of Nvidia is actually making a claim that sounds almost entirely backwards compared to what we hear.
Yeah, it's a fascinating counter-narrative.
He says AI isn't going to eliminate physical blue-collar jobs. Instead, he argues it's going to require this multi-trillion-dollar army of plumbers, electricians, and construction workers just to keep the whole thing running.
Exactly.
So today, we are doing a deep dive into why the very person building the hardware for the AI boom believes this current panic just completely misunderstands how this technology functions in the real world.
And, the source for this perspective comes from a recent Milken Institute interview. It was between CNBC's Becky Kwick and Nvidia's CEO Jensen Huang.
Right.
And when you're evaluating predictions about human labor in, an automated world, Huang is arguably the single most important voice to listen to right now.
Because of their market share, right?
Yeah, Nvidia currently holds an estimated 85% share of the global AI chip market. I mean, he's in some tech blogger just theorizing about the future. His company is reviewing the actual physical purchase orders from the largest tech companies on Earth.
Wow.
He is literally architecting the hardware landscape that makes modern artificial intelligence possible.
That 85% is crazy. It means he has absolute visibility into where the capital is flowing.
Totally.
But looking at this from the outside, I have to ask if this current AI panic is just the modern version of fearing the invention of the calculator.
Or the internet in the 90s.
Right, the initial terror surrounding the internet. We have this long history of panicking over new tools. So, is there a concrete structural argument behind Huang's optimism? Or is he just doing a highly effective job of selling his own silicon?
Well, his argument relies on completely inverting how the public conceptualizes artificial intelligence.
Okay, how so?
Most people think of AI as this ethereal, invisible magic that just exists somewhere out in the cloud. It feels like pure software.
Yeah, exactly.
But Huang points out that generating that invisible magic requires an incredibly heavy, massive physical footprint in the real world.
Yeah.
You just cannot separate the algorithm from the heavy industry required to run it.
Well, the cloud is, let's be real, it's just a physical server sitting in a building somewhere. It has mass, it generates heat, it requires maintenance.
And that physical reality is the absolute foundation of his first major claim, which is that AI is going to act as a massive engine for physical job creation.
Okay.
He argues that this tech represents the United States' best opportunity to radically reindustrialize itself.
Reindustrialize, that's a strong word.
It is. To make AI work at a global scale, Huang lays out the necessity of operating three entirely distinct types of industrial plants. You need chip plants to manufacture the silicon. You need computer plants to assemble those chips into massive server racks. And finally, you need what he calls AI factories to house and operate those racks.
Wait, hold on. I want to stop on that term, AI factories.
Sure.
Because when people hear that phrase, their minds immediately jump to, a dark, fully automated warehouse where robotic arms are just assembling more robotic arms.
The whole sci-fi dystopia thing.
Exactly. If the goal of AI is automation, why wouldn't an AI factory be completely devoid of human labor?
Because the bottleneck in an AI factory isn't the software. It is thermodynamics and industrial engineering.
Oh, interesting.
Yeah, when Huang refers to an AI factory, he is talking about a hyperscale data center. Processing trillions of parameters requires tens of thousands of GPUs running simultaneously.
And those run hot.
Oh, they generate an unimaginable amount of heat. So to build and maintain these facilities, you need thousands of human workers.
Right.
You need concrete layers to pour these highly specialized foundations. You need teams of electricians to route high-voltage industrial power.
And plumbers, too, I imagine.
Yep, HVAC specialists and plumbers to design and maintain the complex liquid cooling systems required to keep the servers from literally melting down.
Wow.
None of those highly specialized physical tasks can be performed by a language model.
So the creation of the software itself actually demands an ongoing army of physical labor just to keep the machines from overheating. The digital revolution is basically tethered to concrete and copper wire.
Exactly. And it goes far beyond the walls of just the data center. The ripple effect extends to foundational national infrastructure.
Like the power grid.
Precisely. Huang points out a really critical vulnerability. The United States power grid is antiquated. It already struggles to handle current peak loads, let alone the massive influx of energy required by these new AI factories.
I mean, a single hyperscale data center can require as much power as a small city, right?
You can.
Which sounds like a recipe for a national energy crisis. If the grid is already fragile, adding a network of power-hungry AI factories just seems like a disaster waiting to happen.
That is definitely the intuitive fear. But Huang views this massive energy demand as a catalyst for long overdue modernization.
How does that work?
The mechanism at play here is guaranteed market demand. Historically, utility companies have hesitated to invest billions of dollars into upgrading the grid or building new sustainable power plants.
Because they didn't know if they'd have buyers.
Right. They couldn't always guarantee a massive, consistent buyer for that electricity over the next 30 years. But AI factories completely changed that math.
Ah, I see.
Because the tech industry's demand for baseload power is so high and so urgent, utility companies now have the financial incentive and the guaranteed customers needed to secure the capital to actually modernize transmission lines and invest heavily in sustainable energy sources.
So the AI boom provides the economic engine to finally fix the grid.
Exactly.
But, I mean, that economic engine comes with a staggering price tag. Completely revamping a national power grid and building 3 different tiers of massive industrial plants is a monumental undertaking.
Is massive.
Where is the capital coming from to actually finance this physical reindustrialization, and how does that funding translate into job security for the listener?
Well, Huang does not downplay the economics of this transition. He estimates that this reindustrialization process will cost several $1 trillion.
Trillions, with a T.
Trillions. And the sheer scale of that capital deployment is what guarantees the associated jobs. And while private market forces are driving the bulk of this, they aren't operating in a vacuum.
Right.
There is significant structural support from the federal government acting to accelerate this domestic manufacturing push. Specifically, the Biden administration passed the CHIPS Act of 2022.
Okay, yes.
This legislation authorized $280 billion strictly to boost domestic semiconductor research, manufacturing, and the associated workforce training.
So by injecting that federal funding to secure the domestic supply chain, the government is essentially de-risking these massive infrastructure projects for private companies.
Exactly.
They are creating a financial environment where building a multi-billion-dollar chip plant in the United States actually makes economic sense.
Right, and that combination of private urgency and public funding is what is currently driving hundreds of thousands of jobs in the manufacturing and construction sectors.
That's a huge shift.
It is. And to understand the timeline of all this, Huang introduces a really helpful framework. He describes the AI industry not as a single product, but as a 5-layer cake.
A 5-layer cake, okay.
And the most important takeaway for anyone worried about the immediate future of human labor is that we are currently only building the very first layer of that cake.
Let's break down the architecture of that cake then. If we are talking about 5 distinct layers of an industry, what exactly does layer 1 consist of, and what does the rest of the stack look like?
So layer 1 is entirely foundational. It's the physical silicon, the networking cables, the cooling systems, and the data centers we just talked about.
The raw infrastructure.
Exactly. Then layer 2 sits on top of that. It's the system software that allows all those massive chips to actually communicate with each other.
Okay.
Layer 3 is the foundational AI models themselves.
Yeah.
You know, the large language models that companies are spending billions to train.
Right, the brains.
Right. Then layer 4 consists of enterprise software, where companies build internal tools utilizing those foundational models.
Mm-hmm.
And finally, layer 5 represents the consumer-facing applications and autonomous agents that the general public will eventually interact with daily.
Oh, wow. Okay, so applying that to a more familiar analogy, if we are only on the very first layer of this AI cake, we are essentially in the messy kitchen phase of this entire revolution.
I like that, the messy kitchen phase.
Right. Like we are currently dragging out the heavy industrial mixers, pouring the concrete floors, and routing the plumbing. All of this heavy lifting requires maximum physical employment before we even get to the point of baking the foundational models, let alone decorating the consumer applications at layer 5.
That analogy captures the current economic reality perfectly. We are just building the kitchen.
Yeah.
The infrastructure phase is inherently capital-intensive and labor-intensive. It requires millions of human hours to pour the foundation. The AI industry is nowhere near the point where a fully autonomous, polished product is just sitting in a display window replacing human effort across the board.
Well, The demand for blue-collar labor in this layer one phase makes complete logical sense. You need human hands to build physical infrastructure.
Right.
But let's be real, the anxiety surrounding artificial intelligence isn't usually coming from the construction sector. It is coming from the knowledge workers.
The white-collar workers.
Exactly. The
Yeah.
people sitting at laptops analyzing data, writing code, and managing projects. If the end goal of building these massive AI factories is to create software that can outthink a human, how does Huang address the immediate job security of the white-collar worker?
He addresses it by looking at how venture capital is actually being spent right now.
Following the money.
Always. Huang highlights a statistic regarding the startup ecosystem that really challenges the narrative of immediate human replacement. He notes that out of the roughly $100 billion invested recently into various AI startup companies, the overwhelming majority of that capital did not go toward buying servers or purchasing raw compute power.
Where did it go?
It went directly to payroll.
Wait, really? But if the core product is an artificial intelligence, what are all those human employees actually doing?
They're building the companies around the algorithm. I mean, when an AI startup secures $1 billion in funding, they don't just turn on a machine and walk away.
Right.
They have to hire product managers to figure out what the market actually wants. They hire legal teams to navigate the massive copyright and compliance issues that AI creates.
Oh, the legal issues are huge.
Massive. They hire marketing departments, enterprise sales teams, human resources, and surprisingly, they hire massive numbers of software engineers. The capital flows directly into the human economy.
Okay, the software engineering aspect is where the logic seems to break down for me.
How so?
Well, Huang talks about this concept of dislocation, the friction and anxiety that happens when people try to compete against the technology instead of utilizing it.
Right.
But if we look at the raw mechanics of coding, an AI can generate a functional script in seconds. It writes clean syntax faster than a human ever could.
True.
So basic business math dictates that if a machine can do the heavy lifting of writing code, a tech company doesn't need a team of 20 engineers anymore. They only need 2 engineers to oversee the AI. How can the market possibly be hiring more software engineers if the tool makes them mathematically less necessary?
You know, that paradox is the most profound insight of the entire interview, and resolving it requires us to completely redefine what the job of a knowledge worker actually is.
Okay, redefine it how?
Well, Huang argues that assuming coding jobs are dead fundamentally misunderstands the mechanism of software development. He states clearly that the core purpose of a software engineer was never just to write code.
It wasn't.
No. The purpose of a software engineer is to solve complex human problems and architect new systems.
So typing the actual syntax, like the C++ or the Python, was just the manual labor required to communicate a solution to the machine.
Exactly.
We confuse the tedious mechanical process with the actual value of the job.
Precisely. If the machine can now handle the tedious translation of syntax, the human engineer is freed up to focus entirely on system architecture and problem solving.
Oh, I see.
This introduces the economic principle of induced demand.
Induced demand.
Yeah. When the cost and time required to write code drops to near zero because of AI, a company doesn't just build the same amount of software and fire all their engineers. Instead, the demand for software solutions skyrockets.
Because it's cheaper.
Because it is suddenly cheaper to build. Companies attempt to solve thousands of micro problems they previously couldn't afford to address. So they end up hiring more engineers to architect those new solutions using AI to rapidly generate the underlying code.
So we have viewed the software engineer like a ditch digger being replaced by an excavator. But Huang is suggesting they are more like a city planner who suddenly has access to unlimited excavators.
That's a perfect way to put it.
The job doesn't disappear. The scale of what they can build just expands exponentially.
And that expansion requires a completely different skill set to manage.
Yeah.
Which brings us to Huang's philosophy on long-term career survival.
Okay. What's his advice?
He tells audiences that understanding how to prompt and utilize AI is just the baseline now. But the actual competitive advantage for a human worker relies entirely on soft skills.
Really? Soft skills?
Yeah. He argues that people must approach these new technological tools with life experience, judgment, and wisdom, rather than looking at business problems from a strictly technical viewpoint.
Man, that is a massive paradigm shift for the modern workforce.
It really is.
For the last 20 years, the universal career advice has been to acquire hard technical skills. Learn to code, learn to run data regressions, learn the mechanics. But Huang is suggesting that as AI perfectly commoditizes those hard technical skills, the market value completely shifts back to uniquely human traits.
because life experience cannot be programmed.
Right.
Wisdom cannot be scraped from the internet and downloaded into a language model.
Right.
I mean, an AI can instantly write the perfect code to build a consumer application, but the AI does not have the human empathy to know if people will actually find that application intuitive to use.
It doesn't know what it feels like to use it.
Exactly. It doesn't have the context to know if the software solves a genuine emotional or logistical frustration in a human's day-to-day life. The AI possesses the technical execution, but it entirely lacks the context of the human condition.
Wow. So if human context is the new premium skill, it means the workforce has to transition from being task executors to being managers of artificial intelligence.
Yes.
We have to understand the nuances of human behavior to direct the machine toward a useful outcome. But does that mean the transition will be entirely smooth and everyone just keeps their current job with a new job title?
Not exactly. Huang is highly pragmatic about the friction of this transition. He explicitly states that every single job will be impacted by this technology.
Every single one.
Yes. Some roles that are entirely reliant on repetitive mechanical execution will be eliminated. But he maintains that the net result will be the creation of millions of new opportunities for workers who adapt.
Right.
The critical failure point for a worker today isn't being replaced by an AI. It is being replaced by another human who knows how to use an AI to solve problems faster.
Right. That makes sense. So to pull all of these threads together for you listening, the overarching narrative here is a complete rejection of the standard doomsday scenario.
Absolutely.
Artificial intelligence isn't an ethereal threat floating in the cloud waiting to delete human labor. It is, right now, a massive multi-trillion-dollar physical reindustrialization project.
Yeah.
It requires armies of skilled tradespeople to pour concrete, route high-voltage power, modernize our national grid, and build the actual facilities that house this technology. We are firmly in the messy, labor-intensive Layer 1 phase of building the infrastructure.
And for the knowledge workers, the transition requires letting go of the mechanical tasks that used to define our daily routines.
Yep. The future belongs to those who view AI as an infinitely capable intern. You no longer have to type the syntax or format the spreadsheet, but you are entirely responsible for architecting the strategy, applying human judgment, and ensuring the final product actually serves a real-world human need.
Which leaves us with a critical, lingering question to consider as this shift accelerates. Huang makes a really compelling case that our future value as workers lies in our human wisdom and our life experience, rather than our ability to mechanically execute entry-level tasks.
Yes, he does.
But historically, the way young professionals gained that crucial wisdom was by grinding through those exact entry-level tasks.
That's a great point.
We learned the architecture of an industry by formatting the spreadsheets, finding the syntax errors, and making the tedious mistakes. You cannot just enroll in a college course to learn life experience.
No, you can't. So if artificial intelligence flawlessly automates all the tedious ground floor work of an industry, how does the next generation of 22-year-olds actually get the hands-on reps required to develop the wisdom they need to eventually manage and command the AI? If we no longer have to perform the foundational mechanics of our jobs, how do we ensure we still understand how the machine works?